Okay, in this lesson, we're going to look at solving absolute value equations, and these absolute value equations will have a single absolute value. This is a continuation of a previous lesson, and in that previous lesson, you learned this. You learned that the absolute value of A equals B. So when you have this absolute value equation, you have that single absolute value. So whenever you have that absolute value expression by itself on one side of the equation, then you can rewrite this as two separate equations. So when you rewrite this, and again, it's important that you rewrite it just like this, you will say, when you rewrite it without the absolute value bars. So you're going to see that those two equations are not going to have absolute value bars. So this absolute value equation is true when A is equal to B. So what's inside the absolute value bars equals the other side, or A equals the opposite of what's on the other side. Okay? All right, so that's how you're going to rewrite these absolute value equations. So let's look at number one. So we're going to see how this applies. So number one, we have the absolute value of 2x minus 5, and then you're subtracting 14, and that's equal to a negative 4. Okay, so we have this absolute value equation. Before I can split it apart into two equations without absolute value bars, I've got to first of all get this absolute value expression by itself. So right now I'm subtracting 14, so the opposite I'm going to do is add 14 to both sides. And so when I combine like terms, I get the absolute value of 2x minus 5 is equal to, and a negative 4 and a positive 14 is 10. All right, now at this point, that's where I'm going to split it up. So I'm going to use this idea now. So you see the absolute value bar is by itself. And so when I rewrite it, I'm going to say 2x minus 5 is equal to a positive 10, what's on the other side, or 2x minus 5 is also equal to the opposite of what's on the other side. So that's how you're going to rewrite those two equations. Now notice that I went from an absolute value equation to two linear equations. All I have to do is solve these linear equations. So I'm going to add 5 to both sides. So I get 2x equal 15. Divide both sides by 2. I found one of my solutions. So one of my solutions is 15 halves. All right. And just real quickly, you can check this, but keep in mind that on a test or a quiz, as long as this statement, as long as when you get the absolute value by itself and this is a positive number, if you do this correctly, you should be good to go. Um, so if you want to check though, you just go back to the original. You have to go back to the originals because you could have made a mistake anywhere along this process. Always go back to the original. So I'm just going to check the first one. So the absolute value of 2x minus 5 minus 14, and I want to see that expression when I substitute 15 halves for x will equal a negative 4. Okay? All right, so here we go. The absolute value of 2 times 15 halves minus 5, and then whatever this, I'm subtracting 14. Well, 2 times 15 halves, the 2's divide out, and you get 15 minus 5, which is 10, and the absolute value of 10 minus 14 will give me, remember the absolute value of 10 is 10, and 10 minus 14 is a negative 4, which is what you wanted. Okay? All right, so that's how you can check these. All right, now let's do the other one. It's right here. So I'm going to add 5 to both sides. And so when I combine like terms, I get 2x equals a negative 10 plus 5 is a negative 5. Remember, this is 0. Negative 5 plus 5 is 0. Divide both sides by 2. I get my solution to be a negative 5 halves. So those are your solutions. And again, you can check this and you'll see that it does work. All right, so that was number one. Okay, so let's look at number two. Number two, we have, number two, we have 6 times the absolute value of 3x minus 1, subtract 5 equals 2. All right, so that's what we have. Okay, now let me just say a couple of things here. Just like we did in the previous problem, remember before you can split it apart, you do need to get the absolute value expression by itself. And notice that this number in front is a 1. All right, so notice here though that that's a 6 right here. So at some point I only need the absolute value bars, the expression inside the absolute value bars by itself. Okay, now so the first thing we're going to do, just like we did with the previous problems, we're going to add 5 to both sides. First thing you're going to do. And so when I do that, I get 6 times the absolute value of 3x minus 1 is equal to 7. Okay, now, there are a couple of things you can do here. And we're going to do it both ways. So notice I have a 6 here. Before I can rewrite it into two equations without absolute value bars, this right here has to be a 1. All right, so a couple of things I can do. I can first of all, and I'm going to go ahead and rewrite it so you can see this. I can first of all divide both sides by 6, just like that. And then notice that 6 divided by 6 is 1, so I get the absolute value of 3x minus 1 is equal to 7, 6. All right? And now you see how the absolute value bar is by itself? So now I can split into two equations. I get 3x minus 1 equals 7, 6. 3x minus 1 equals a negative 7, 6. So notice that the expression is on the left, and you have 7, 6 and a negative 7, 6. All right. Now, I want to mention this as well. Whenever you're solving this kind of equation, this kind of absolute value equation, where you get an absolute value expression equal to a number on this side, then always make sure that this is positive. All right, make sure this is positive. If this is positive, then you go on. You're going to get solutions. All right. Okay. Now, you may need your calculator for this to make things a little bit quicker for you. But notice I'm going to add 1 to both sides, so I get 3x equal. Now let's use a calculator in that part. So I need to add 7, 6 plus 1. Now adding 1's easy here because 1's the same thing as 6 over 6, right? So 7, 6 plus 6, 6 is 13, 6. So that should be 13, 6 here. But if you didn't see this, then use your calculator. You're going to say 7 divided by 6 plus 1 equal, and you get this decimal. Now notice that this decimal doesn't terminate. You see how the 6's keep repeating? Okay? So to change this to an improper fraction or to a mixed number first, you're gonna see this DRG right here. So you're gonna press DRG. Oops, sorry, excuse me. You see this PRB, excuse me. PRB, you can press second. See where it says F to D in blue? So you gotta press second. And I'm not sure if I did this already, so I may have to redo this. PRB, okay, no, we're good. So you can get this and then press equal, and now you get this mixed number. So that's 2 and 1, 6. So this right here is 2 and 1, 6. Well, as an improper fraction, this mixed number, 6 times 2 is 12. 12 plus 1 is 13. You get 13, 6. And that's what you got here. All right, and then finally, you can divide both sides by 3. By 3. Now, let's remember how to deal with this from previous courses. So see, when you have a fraction divided by a fraction, see 3 is a fraction because you're going to write 3 over 1. You got to change this division to multiplication. So you're going to say 13, 6 times, and the reciprocal, whenever you change this division to multiplication, you got to take the reciprocal of 3, which is 1/3. And then reduce if you can. I cannot reduce, so I get x equal 13. 13 times 1 is 13. 6 times 3 is 18. So you get 13 18ths. Okay? All right, let's do this one. So over here, you're going to add 1 to both sides. And so when I add 1 to both sides, this is 0 here. So I get 3x equal. And again, if you want to go off to the side, if you don't have a calculator, you would have to do this. You'd have to say 7, 6 plus 1 over 1, which is equivalent to 7, 6 plus 6 over 6. Because remember, 1 same thing as 6 over 6. But a negative 7, 6 plus 6, 6 is a negative 1, 6. So that's what would go here. Now, if you have a calculator, let's review how to do this. Now, make sure you're using the scientific calculator you have. Make sure you know how to use it. Okay, so we had negative 7, 6 plus 1, right? So you're going to say, here's your negative button. So you're going to say negative 7 divided by 6, 7 divided by 6 plus 1, press equal. All right, so you can get this decimal. And then to get this to a fraction, you're gonna press that. See where it says PRB? You want the blue though, the F to D. So you press second, and then PRB. Okay, get fraction, decimal, decimal, fraction. Press equal, the equal button, and you get negative 1, 6. All right, and that's what you got here. And then to get x by itself, remember you got to divide by 3. And so 3 divided by 3 is 1, so x equal. Okay, now notice though that this is a fraction divided by a fraction. So you have this complex fraction. So you're going to say negative 1/6, negative 1/6 times the reciprocal of the denominator, which the reciprocal of 3 is 1/3, and then reduce if you can, but I cannot reduce here. So negative 1 times 1 is negative 1. 6 times 3 is 18. So there's your other solution. Okay? Now, let me go back here. So remember, the way we did this was we divided both sides by 6. All right, now, listen carefully to what I'm about to tell you. So as long as this number right here is positive, as long as it's positive, you can use a distributive property. You can distribute this positive number inside the absolute value bars. So let's go ahead and do that. So in other words, I'm going to go right here. Oops. I'm going to go right here. I'm going to rewrite this over. 6 times 3x minus 1 equals 7. So as long as this is positive right here, I can distribute. And so I get the absolute value of 6 times 3x is 18x. Don't forget, though, you still have that absolute value bar, so don't throw that away. And then 6 times a negative 1 is a negative 6, equal 7. And now, right away, see you have a 1 here, so now you can write into two separate equations. And so you get 18x minus 6 equals a 7. 18x minus 6 equals a negative 7. And then you solve the linear equation, so you add 6 to both sides, and so you get 18x equals 13. And then watch, I want to show you something. 18x equals 13, right? See right here that 18 and that 13? So you don't have to deal with all these fractions here. But as long it's got, remember, as long as this is positive, okay? All right. And so divide both sides by 18, you're done. You found your solution. X equal 13/18. Over here, add 6 to both sides. I get 18x equal negative 1. Divide by 18. You found your other solution. So again, this you can distribute within the absolute value bars if this is positive coefficient out here. All right. So that was number 2. Okay. So let's look at number 3. All right, number 3, we have this now. Okay, now notice this time I have x plus 6, the absolute value x plus 6, but there's a negative out here. And then minus 7, and then equal negative 10. Okay? All right, so remember, before you can rewrite this without absolute value bars, remember those two equations? So whenever you have an absolute value equation, you're going to end up with two equations. You got to get the absolute value bar by itself. So we got to, first of all, get rid of the subtract 7. So the opposite of subtracting 7 is to add 7. And so I get the negative, or the opposite of x plus 6, the absolute value of x plus 6 is equal to, this is 0. A negative 10 plus 7 is a negative 3. All right, now here's where you got to be careful. See, there's a negative out here, and this is not parentheses, this is absolute value bar, so it makes things a little bit trickier. All right, so that's not parentheses. If that's parentheses, then you could distribute very easily. But since that's a negative out here, and this is understood to be a negative 1, you need to first divide both sides by negative 1. Don't distribute. Do not distribute. You divide both sides by negative 1. And so negative 1 divided by negative 1 is 1, and then 1 times the absolute value of x plus 6 is the absolute value of x plus 6. Equal, and then negative 3 divided by negative 1 is a positive 3. And so then we get, now we have the absolute value by itself, so we can rewrite this as two separate equations. So I get x plus 6 equals 3, x plus 6 equals a negative 3. And then again, notice that, see this absolute value bars right here, this absolute value expression, and then that's a positive number. So that means that you can go ahead further. All right, and so subtracting 6 from both sides, I get x equal, this is 0 here, so I get x equal to 3, subtract 6 is negative 3. So that should be one of your solutions. Over here, subtract 6. I get x to be a negative 9 because a negative 3 and a negative 6 and negative 9. All right, and let's check one of them. Let's just check negative 9. Let's check that one. All right, remember you must go back to the original. All right, now, okay, so let's go back to the original. So I'm going to rewrite the original over. I'm going to do that here. So we had this as the original. Okay, all right, so here's what we have. So in place of x, I'm substitute negative 9, so I get this. The opposite of the absolute value of negative 9 plus 6 minus 7. And I want to see that's equal to negative 10, right? All right. The absolute value of, well, first of all, negative 9 plus 6 is a negative 3. Okay. Just rewrite everything else over. The absolute value of negative 3 we know is 3. So this becomes a negative, remember this is 3 here. The absolute value of negative 3 is 3. And a negative 3 and a negative 7 is a negative 10. Okay? All right, now I want to say this though. All right, so that's what you would do. So it's very important though you understand this, that whenever you have a negative coefficient here, at this point here, whenever you have a negative coefficient, you must divide by that coefficient. Okay, now here's why. Okay, so I want you to pay attention to this. If you had distributed, so this is wrong right here, okay, and you're going to see why. If you had distributed, you would have gotten this. Okay, distributed here. So this is wrong though. Okay, you would have said the absolute value of negative x minus 6 equals a negative 3. Okay, but you got to remember at that point, that statement doesn't make any sense because the absolute value of of a number, whatever value you plug into x here, is always going to be positive. This is always going to be positive. A positive will never equal negative. But you saw that we have solutions, right? There are solutions. All right, so be careful. I'm going to say this. If you do split it apart like you did here, you will get these solutions. You will get these numbers here. But your statement is mathematically incorrect. This statement is not correct. So the statement is not true. Okay? But if you do split it apart, you're going to get these, but you're not going to get full credit because when you wrote it like this, that wasn't a true statement. This is always going to be positive, and a positive is never negative. All right, so that's why it's important that if this is negative out here, don't distribute. You must divide first. So you can get, if there are solutions, so you can get an expression, an absolute value expression that's equal to a positive number. All right, so this must be positive, not negative. All right, so it's a little bit tricky for students. It does get, the understanding of this part does take a little while to get used to. Okay? All right, so that's number 3. Let's look at one more dealing with this. So let's look at number 4. Number 4, actually we're going to do about 2 more. Okay, number 4, we have the absolute value of n minus 3 plus 8 equals negative 2. I'm sorry, positive 2. Positive 2. And it didn't matter if it was negative 2 or positive 2. The intent of what I'm going to want to do is still the same. So I'm going to subtract 8 from both sides because I have to get the absolute value bars by itself. So I get the absolute value of n minus 3 is equal to negative 6. All right, now at this point, remember we talked about here. At this point, remember you have the absolute value bars by itself. Whatever I substitute for n, this is always going to be positive. A positive is never negative. Okay? Never negative. So that means that this original absolute value equation has no solution. No solution. So you would say no solution. Okay? Now sometimes in my math lab they'll use the symbol, the empty set symbol, so you'll see this sometimes. All right? Now, let me say this. I'm going to say this again. Some of you are going to make the mistake, because you could see right here that there is no solution. Okay? There is no solution. You're going to make the mistake and you're going to split it apart. Okay, so this is a mistake that you're going to make. some of you will make. And you're going to say, well, n minus 3 equals a negative 6, n minus 3 equals a positive 6. And then you're going to add 3 to both sides, and so you get n to be negative 3. You're going to add 3 to both sides, and you get n to be 9. The mistake you're going to make here is that you're not going to check. So you must check for this one. You may say, well, you say we didn't have to check for the others. Yeah, you're right. You're right. You didn't have to check because when I got to this point here, the absolute value expression was equal to a number, and that number was positive. So we're good. Whatever you get here, if you check it, it'll work. It will work. But here, that's not a positive number. So if you understood what was happening here, if you understood the idea of absolute value, remember the absolute value measures the distance that a number is from 0 on the number line, and so distance, if this is a and this is negative a, distance is always positive. Distance is always positive. Okay, so if you check this, if you check negative 3, watch what happens. Let me go ahead and rewrite this. All right, so if you check negative 3, you're going to get the absolute value of negative 3 and a negative 3. Negative 3 subtract 3 plus 8, and you want to see that's going to equal 2, right? Well, the negative 3 and a negative 3 is a negative 6. And the absolute value of negative 6 is a positive 6. 6 plus 8 is, what's that, 14? And that's not equal to 2. So that's not true. All right? So that's why you got to be careful. And you do the same thing with 9, you're going to see it's not going to work either. Because look, 9, I'm doing it without writing it, 9 subtract 3 is 6. The absolute value of 6 is 6. So we get 6 again. 6 plus 8 is not 2. All right, so always remember that if you have an absolute value expression equal to a negative number, you're going to say no solution. Now, you may say this, well, right here, you didn't say there was no solution. You are right. I did not say the answer is no solution. We do get solutions here. What I was saying here was that the mistake is that if there's a negative out here in front of the absolute value bars, the mistake is to distribute. That's the mistake. You must divide. You must divide. If this is negative, you have to divide. Okay? And then once you divide, notice I got a positive number here, so I'm going to get solutions. Okay, so that was number 4. I want to do one more because you may see some fractions involved in this. So let me do one more with fractions. So this is going to be number 5. And then the next video will have a bunch of fractions in it if you need to review fractions. But here's number 5. We have x, the absolute value of x plus 5 divided by 2, subtract 3, equals 4. All right, so don't let the fact that you see a fraction here throw you off. The idea is the same. You have enough experiences from previous courses to help you get through this, and you also have access to a calculator. But the first thing you got to do, remember, is to get the absolute value bars by itself. And a good thing here is knows that that's a 1, so that helps. So we're going to add 3 to both sides. And then when I do that, I get the absolute value of x plus 5 divided by 2 is equal to, and then this is 0, and then 4 plus 3 is 7. And at that point, you're going to split it apart. Because notice, you do have an absolute value expression equal to a positive number. As long as this is positive, you're going to get solutions. Okay, x plus 5 divided by 2 equals 7. X plus 5 divided by 2 equals a negative 7. All right, so let's look at this one. So let me go ahead and rewrite this one over so I have more room. So at the beginning of the semester, and even in previous courses, but you did have lessons beginning of the semester where you had a linear equation that had a fraction involved. So notice that this is a 2 and this is a 7 divided by 1, so the LCD is 2. So you're going to multiply both sides by 2. And so when I multiply both sides by 2, these 2 divide out, and you get x plus 5 is equal to 14. And then solving this linear equation for x, subtract 5 from both sides, you get x to be 9. And there's one of your solutions. And you can check it. So I'm going to say it in words, though, so let's check it in words. 9 plus 5 is 14. 14 divided by 2 is 7. The absolute